Part 2 of finals review for Honors Algebra 1. We've done the first 7 pages, and now here are the next 7 pages. Solve the equation S equals A plus L times W for the variable W. Well, we're going to subtract A from both sides. We're going to divide both sides by L, and we get S minus A over L equals W. Solve the system of equations by elimination. We had mentioned that there are 3 ways to do that, but this one specifically mentions doing elimination. So what I'm going to do is multiply the top equation by 2, and that will give me negative 12x plus 8y equals negative 4, and then I will add these 2 equations. That was a plus sign. 12 plus negative 12 is nothing. Negative 8 plus 8 is nothing. So we get 0 equals negative 16, and that's just simply not true. So there is no solution. What that means, by the way, is these 2 lines are parallel. They never touch. Solve this by factoring. Well, we can do the x, we can do the x thing. 2 times negative 4 is negative 8, and our b is 7. So what factors of 8 could possibly give us 7? Let's see, there is 8 and 1. How about positive 8 and negative 1? So since a is not 1, what we're going to do is factor by grouping. And what that means is I have taken, I've taken 7, and I've rewritten it as 1, negative 1, plus 8x. And maybe you already knew that, maybe you didn't, I don't know. But here we go. Now I'm going to factor each group. In this blue group, I have an x in common. So it's 2x minus 1. In this green group, they have a 4 in common. So I have 2x minus 1. And oh my goodness, now they both have a 2x minus 1 in common. So I'm going to factor out 2x minus 1. And what I have left over here is that blue x, specifically right there. What I have left over here is this 4, specifically a positive 4. And then all of that equals 0 still. So this left-hand side, if I were to do 2x minus 1 equals 0, I'd add 1 and then divide by 2. So 1/2 is one solution. And this one, x would just be negative 4. Because if I had x plus 4 equals 0, I'd subtract 4. What is the discriminant of the equation, blah, blah, blah? The discriminant is specifically here. I'm going to write D for discriminant. D for discriminant is b squared minus 4ac. And in fact, what the heck is that? Well, this is in the form ax squared plus bx plus c, which means that a is 2, b is 3, c is 4. And so I'm just going to take this and plug it in here. So b squared minus 4ac, 9 minus, let's see, 16 times 2 is 32. We get negative 23, right? And what that means, if my discriminant is negative, I have no real solutions. And in fact, I don't know what that means. If I were to graph this thing, it would look like this, meaning it does not cross the x-axis, therefore there are no real solutions. This problem is super old school. It says identify the domain and range. So the domain is literally just, we have an x, a 10, a 15, and a 20. I forgot my 5. 5, 10, 15, 20. And I know that because, 1, they're all written over here, but 2, they all have connections, right? And then over on the range side of things, I hit negative 3, negative 1, 1, and 3, negative 3, negative 1, 1, and 3. And is this a function? Yes, because there are no repeated x's. Pretty much, if you repeat an x, and what would that look like, by the way, is if we did this. Let me make it a little larger and more obvious. If 5 went also to negative 3, well, that means that 5 got mapped. This is a map, by the way. Gets mapped to negative 3 and to 1. and that is not a function. It would fail the vertical line test. And then my way that I like to think about this is if you go to a pop machine and you hit Coke and it gives you Coke, you're thinking, cool. But if you hit Coke again and it gives you Dr. Pepper or Pepsi, oh my gosh, that's not the same thing. That machine is not functioning. But this one is functioning, so there we go. Find the product. Well, you could write it out like this and then just distribute or FOIL, or you could remember that this looks like a minus 2ab plus b squared. And in fact, what? Where this is a and this is b. So what that looks like is we would have 4y squared. There's that. Minus 2 times 6 is 12 times another 2 is 24ab. Sorry, not ab, right? 24y. And then plus 36 because b squared is 36. So you can look at it this way, or like I said, you can distribute, and you see 2 times 2 is 4y squared. Negative 12y, another negative 12y gives you negative 24y, and negative 6 times negative 6 is 36. So speaking of which, that is called a perfect square trinomial. So here they are, perfect square trinomial. The thing I like about this is both of these are the same with one little difference. There's a plus here, there's a minus here. And so the plus shows up here, the minus shows up here. So even these two guys are the exact same except for that plus, that minus, that minus. So if you memorize this stuff, cool. If you don't memorize it, you're not going to be like in trouble, but you might have to actually distribute. Now we're going to graph this. Well, our parent function to this is y equals 2 to the x power. And also, this is an exponential function. So what that means is it's going to look like, here's a little miniature version of the graph. It's going to look like that, okay? Where there's an asymptote right here. So we have an asymptote on this one of 0. So it will not cross the x-axis. And how do you know the asymptote? It's pretty much this number out here. Nothing. Because it doesn't fit. It's not that it doesn't fit. It's that the parent function doesn't move up. So this doesn't change that way. You can graph anything if you use a table, if you feel the need to use a table. Here's what I'm going to do. I'm going to plug in 0 first. 6 to the 0 power is 1. So 0, 1. Cool. That's how it should look. Now I'm going to plug in 1, and I get 6 to the first power. That's 6. So 1, 6 right there. And then if I plug in 2, that's 6 squared, which is 36. So there's a reason why I went up to 18 here, because I would have to go double that distance to find 36, and I'm not going to do that. So if we did -1, 6 to the -1, that's 1/6. Okay, that's awfully small right there. And if we went -2, we'd get 6 to the -2, or 1/36, which is so much tinier, right? Like I'd have to zoom way in order to really do that properly. So here we go. It was going to be right here, being infinitely close to 0, but not being 0. And then here it really shoots up really fast. So that's what that looks like. And in case you're wondering, well, what does the parent function look like? Same thing. It's going to have that spot right there. But 2 to the first power is just 2, and 2 to the second power is 4, and 2 to the third power is 8, and 2 to the third power, 2 to the fourth power is 16. So it's still going to have this. It's just going to grow more slowly, but obviously not by, I mean, maybe my graph just kind of sucks, but anyway, it's not as crazy as you might think, the difference. Next, this might terrify you by the look of it, but this problem is actually pretty nice. An outfielder throws a ball to home plate. The ball's path is modeled by this graph, where X represents the horizontal distance of the ball from the outfielder and Y the ball's vertical distance above the ground. What are the coordinates of the vertex of the ball's path? So when it comes to vertex, negative b over 2a is the x part of a vertex, and then you would take this x and plug it in to get the y. And if you're looking at this going like, but where is the a and the b? Again, that's where I'm like, it's actually a lot nicer than you'd think, because this is kind of just written in a little bit rearranged form. We're used to ax squared plus bx plus c, but how this one is written is bx minus plus ax squared. So that means that our a is negative 1 over 500. Again, might seem crazy, but it'll turn out okay. And b is 2/5. So negative b, negative 2/5 over 2 times, negative right there. I was thinking, I messed up. It's not negative, but it's this negative, right? Negative b over 2a, and our a is negative, so that's why this is going to be negative 1 over 500. And again, that might seem kind of terrifying, but watch what happens. When you are dividing by a fraction, you flip it and multiply. So it's really negative 2/5 times negative 500 over 2. And then watch what happens. The 2's cancel, and 5 goes into 500 100 times, and then a negative times a negative is positive. So the x part of our vertex is 100, and that's not that crazy. Now let's plug that in, which I'd mentioned right here. Plugging that in also, not as crazy as you'd think. Let's zoom in and kind of do it right here. Y equals 2 times 100 over 5 minus 100 squared over 500. Well, we get y equals 200 over 5, which is 40, right? And then 100 squared is 10,000 over 500. Well, those zeros cancel, and then negative 100 over 5 is negative 20. So what we get is y equals 20. That's not that crazy. So there's the vertex. X is 100, Y is 20. So there's a couple things we talked about that I feel like I did not expressly update over here. One of those things is that this is the discriminant. And I'm going to go ahead and make it even more obvious. This is the discriminant. And if our discriminant is equal to 0, we have exactly one solution. If d is greater than 1, we have 2 real solutions. And if d is less than 1, meaning it's negative, we have no real solutions. The other thing is when it comes to a standard form quadratic, which is what that is, negative b over 2a equals x. That is the x part of the vertex. So boom, we just updated our list. What is the factored form of this thing? Come on now. We got negative 10. We got negative 3. That's 2 and 5. It's a negative 2 and a positive. Sorry, I can't speak. Negative 5, positive 2. There it is. We're done. Next. The zeros of a quadratic function are 9 and negative 4. Which of the following could be the functions? So here's what I'm going to do. I can factor, maybe, probably factor. Or if not, I could do the quadratic formula. So what I'm going to do is kind of zoom in here and do A. So A was this. We have 36 and negative 5. The solutions to that are going to be 9 and negative 9 and positive 4. So what that means is we would have x minus 9 times x plus 4. And if we were to solve that, we would get positive 9 and negative 4, which is what those are. So this is one of our options. Let's do B. In fact, here, I'm kind of trying to squeeze my work in this random paper thingamajig here. So B is negative 36 and positive 5. So how about a positive 9 and a negative 4? Oh, well, we just kind of saw that it would have to be the reverse of that to be true. So bye-bye B. How about C? So C looks like this. Negative 36 and negative 5. And you might think, oh, well, no, that clearly doesn't work because, I mean, we just did two that are so much like it. Did we, though? Because we kind of have been messing with the sign combinations, haven't we? So the numbers here will be negative 9 and positive 4, which, isn't that what we used here and it worked? So yeah, it actually works again. So that one works. And then D is the kind of like the, okay, are you going to work or are you not going to work? So here's what we have to do. This divided by 5 is really 1/5 x squared minus x minus 36 fifths. Oh boy, I can't factor that. So I will use the quadratic formula. So the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. So that is 1, because a negative 1 is just 1 plus or minus the square root. B squared, well, 1 squared is 1 minus 4 times 1/5 times negative 36 fifths all over 2 times a, which is 1/5. Ooh, this looks like fun. So 4 times, so here's what I'm doing right here. I'm going to have to do this because I don't know if you just happen to know that off the top of your head. We get negative 4/5 times negative 36 fifths is 144 25ths. So it's actually 1 plus 144 25ths, which is 25 25ths plus 144 25ths, which is 169 25ths. Okay. And then we were taking the square root of that, right? So the square root of that is 13 fifths. Not that bad, but still like, yikes, right? So we have 1 plus or minus 13 fifths over 2 fifths. Woo. So what I'm going to do is flip that 5 up. Remember what I said earlier, when you divide by fractions, you just flip and then multiply. So here's kind of what we get. We get 5 plus or minus 13 all over 2. So that's 5 halves plus or minus 13 halves. So 5 plus 13 halves is 18 halves, or 9. And 5 minus 13 halves is negative 8 over 2, or negative 4. Do you remember what we're even doing? We are finding out if 9 and negative 4 are solutions to that thing, and check it out. 9 and negative 4 are indeed solutions that work for that. Solve the system by graphing. So the first one, this problem, is super easy because it's in slope-intercept form, meaning the y-intercept is 1 because it's right there. The slope is 3, so we're going to go up 1, 2, 3 over 1. I also like to go down 1, 2, 3 and over 1. And then I was about to use the little ruler function on here, but I realized I am just so good at drawing straight lines, he said sarcastically. Next is this one, which is in standard form. And remember, I like to call this the slap one because I'm going to slap the x, and then I can find the y-intercept. So I just solve this for y, which is negative 4, right there. And then I'm going to erase my slapping because I'm not really mad at the x. And I'm going to slap the y. And then x is just 8. So there's 5, 6, 7, 8 right there. And now maybe I do want to go ahead and use my little pretend ruler. I don't even know if you can see it on the screen as I try and use it, but here I go. So there we go, ruler, engage. So this thing crosses at what I think is about -2, -5. And here's where I'm going to do the math. And I'm going to plug this in, how about right here? So it would be -2 minus 2 times -5. Does that equal 8? -2 plus 10 sure does equal 8. So there's my answer, and obviously there's my graph. Which inequality does this graph represent? Well, here's a y-intercept, and I can use that because if I have y equals mx plus b, then right now I have y equals mx minus 2. And then what I can do from there is go up and over until I find a really good intersection. So I don't like it here or here or here or here, but I love right there. So that is up 1, 2, 3, 4, 5, and over 2. So we have y 5 over 2x minus 2. And now we need to talk about, we're shading down, so it's going to be less than. And then this is a solid line, so it's less than or equal to. And if you're not convinced about that part, then we can always plug in a test point to determine if we're right or not. So since 0, 0 is not being used, is 0 less than -2? No, it's not. So that's why we're not shaded over here, and in fact, why we are shaded over here. Solve the system by substitution. Well, neither of these are already set up for substitution, but that's not really that big of a problem because this is just a regular old y. So what I'm going to do is add 2x to both sides of just this top equation, and I will get this. I will get y equals 2x minus 10. And what I can do is take that and plug it in right here. So I'm going to get 4x plus 7 times 2x minus 10 equals 20. 4x plus 14x minus 70 equals 20. 18x equals 90, so I divide by 18, and I get that x equals 5. I can take that 5 and plug it in here if I want, or I can plug it in here if I want. I'm going to plug it in here because I already have y by itself. So y equals 2 times 5 minus 10. That's y equals 10 minus 10, so y equals 0. Line J passes through point 2, 0 and is perpendicular to the graph of that thing. So I'm going to kind of do some underlining. This is that. And then there's this guy in the middle. And then it says line K is parallel to line J and passes through this point. What is the equation in slope-intercept form of line K? So we want the blue one. Well, when we are going to figure out any of this stuff, we're going to need a slope, especially if it's going to be in slope-intercept form. So line J, if it passes through this point and is perpendicular to this, line J's slope is -4 because negative reciprocals or really super opposite slopes are perpendicular. So, and in fact, what's a reciprocal again? Flip this upside down. Now, line K is parallel to line J, and that means that it has a slope of -4 because parallel lines have the same exact slope. Now, what I'm going to do now is go look at point slope form, which is y minus y1 equals m times x minus x1. And I'm going to plug in this info and this info. So I'm going to be y minus 6 equals -4 times x minus -1. Now, no, that is not in slope-intercept form, but it will be soon because I can simplify this to be y minus 6 equals negative 4x minus 4, right? And I just add 6 to get y equals negative 4x plus 2, and I'm done. Find the value of this. Well, just because of the order of operations, we're going to do parentheses first. So the square root of 5 squared plus 14 squared, not 14 squared, 12 squared. That's 25 plus 144. That's 169, and the square root of 169 is 13. Technically, I guess you could say it's plus or minus 13, but we will move on. Sketch the graph of this function. Okay. Well, the parent function of that looks like this, roughly. And that parent function is specifically y equals x squared. So what we're going to do is move it right 1. We're going to move it up 4. And we're going to flip it. So I can literally take this graph and go, all right, right 1, boom. Up 4, 1, 2, 3, 4. It's there. Now to flip it. Well, you know what? Here's kind of the fun part about this. Because I know about the parent function, I know that I can just go over 1, down 1, and there's a point on the graph. I can go over 2, so 1, 2, and down 4, 1, 2, 3, 4, and there's another point on the graph. And then because of the axis of symmetry, I can do the same thing. I just have to go over 1, down 1, over 2, down 4. Hang on, let me erase that because I don't want it to be a little confusing. And now I'm done. So here's the graph right here. If you don't believe me, or if you're not as confident as I am in my graphing, you could always do a table. You could technically, set this equal to 0 and then solve it to get some things. This is in vertex form, so you know actually that the vertex is 1, 4. So I'll go over here and kind of write some thoughts about that right now. So without getting too crazy, you remember that this is what a parent function kind of looks like when all of the children's options are put in. So A is like the slope and that it's going to flip it or could compress it or stretch it. This is the X in jail. He moves left and right and he's not very truthful. So if this says -3, it's actually you're going to go to the right 3. And this is the guy outside of jail. Very nice, very trustworthy. Could go get on a plane or a submarine right now. I don't know where he's going to get a submarine, but he could. This goes up and down. Does the system have no solution or infinitely many? Well, since those are our only options, that kind of gives us some insight as to how we could technically proceed with this. So, for example, I'd said that, hey, we can graph this. We can use substitution. We can use elimination. We could also rearrange these things. So, like, technically speaking, I could rearrange this to solve for y. And that would be 3y equals 2x plus 6. And if I divide by 3, I get 2/3 x plus 6 divided by 3 is 2. So this is identical to this. And that means there are infinitely many solutions because they are the same exact line. Now, had I taken this and plugged it in right here, let me show you what that looks like. So 3 times 2/3 is 2. 3 times 2 is 6. And notice that 2x and negative 2x and 2x cancel. Does 6 equal 6? It sure does, which means it is still infinitely many solutions. Simplify the radical expression. Leave it in the simplest radical form. So we're going to take 80. That's 2 times 40. That's 2 times 20. 2 times 10. 2 times 5. We're looking for perfect squares, also known as couples. Couples go out. 1, 2 goes out. Another 2 goes out. That means 4 is out. And this 5 stays home. And then this is 3 perfect squares, so a cubed is on the outside. We're done. Factoring this could go one of a couple ways. It could be a little frustrating if you just automatically start and you're like, 12 times 90 is 1,080, and I need to make that equal -6. Yikes, that would be a little daunting. But did you notice the greatest common factor, who I've referred to as Mom before? Mom is just like there for us. And sometimes we overlook her, and that's a bummer. But what I mean is the greatest common factor is what each of those have in common, and it's 6. And now this is a whole lot nicer, because 2 times 15 is -30, and we need the factors to equal -1. That's way easy, because it's -6 and 5, right? So we're going to factor this by grouping. 6 is 2y squared minus 6y plus 5y minus 15. 6 is now multiplying 2y, y minus 3, plus 5, y minus 3. And here, each of them has a y minus 3. So this 6 stays, y minus 3 gets factored out, and then 2y plus 5 is left behind. Now we're done. How does the graph of the function, that guy, differ from that guy? It is simply, here, I'll write out the whole thing, a times b to the x minus h power plus k. As I explained here a moment ago, h is in jail with the x. It moves left and right. K is outside. It moves up and down. So we don't have a k here, right? We just have the x. So it's going to move to the left 2. You would think it's going to move positive, but remember, it's already negative. So it's the opposite. The function h of t equals -16t squared plus 18t models the height and feet of a jaguar t seconds after it jumps to the nearest foot. What is the maximum height of the jump? To find a maximum, you need a vertex, and -b over 2a is going to give you the x part of the vertex. This is ax squared plus bx. So we're going to have -18 over 2 times -16. And you might think, oh my gosh, that is just terrible. It's not that bad. So you get -9 over -16. How'd that happen? Because those kind of cancel each other like that. And then that's it. So the x part is those two, because it doesn't really reduce. So what we're going to do is take that and plug it in here. -16 times 9/16 squared plus 18 times 9/16. So what's going to happen here is one of these 16s cancels one of these 16s, because there are 2 of them. And then don't forget that there's 2 9s. So we have -81 over 16 plus. And you know what? I'm going to go ahead and leave this 16 alone. I'm not going to cancel at all with those 2. I'm just going to do 9 times 18, which is 90 plus 72. So 162 16ths. And if you're like, why did you not go ahead and do any kind of canceling? Because now I have common denominators, right? -81 plus 162 is actually 81 over 16. So that is the height that this jaguar has jumped. Was it a jaguar? Yeah. And if you really are curious, you could figure out the decimal, which is 5.0625, 5 feet off the ground. Write an exponential function for the set of points. Well, what's happening is we are multiplying by 2, multiplying by 2, multiplying by 2, multiplying by 2. So what that means is it's going to be, well, here's our parent function. Actually, here are the kids. But they are not evil, so they did not include that or that. And in fact, how do I know that? Because they're right here, okay? And because these are going up by 1, up by 1, up by 1, up by 1, it would be more complicated looking in a table. Just trust me. So what we actually have is y equals, I'm going to go ahead and just call it blank for now, times 2 to the x power. Where did I get that to? Right here. And then now I'm going to write 6. Where did I get that 6 from? Right here. Because if I were to plug in 0 right here, I would get 2 to the 0 power, which is 1. And 1 times 6 is the only way we could get that 6. So y equals 6 times 2 to the x power. Write a compound inequality for the graph below. Well, we are at -4 and we're at -1, I should say. So x is happening in between those. So look, I wrote x in between -4 and -1, but I'm actually a filled in dot. So I'm going to put an equal to symbol on both of those. Find all the values of k so that this trinomial can be factored using integers. So we're going to use our big X here, and a times c is 30, and then we want them to equal k. Well, so the factors of 30 are like this. So whenever we're trying to find k, we want these factors to add or subtract. So we could have 31 and 17 and 13 and 11. And I'm going to stop there because this is positive and this is positive, which means I cannot have two negatives. And if you're like, well, you could have one to be negative. Nope, we cannot. So our answers are k could be 11, 13, 17, and 31. And if you're not believing me, what we could do is go, all right, well, if we had -1 and -30, that would be -31. So is x squared minus 31 plus 30, does that work? Well, let's find out. 30 and 31. So we could have -1 and -30. Well, hold up, hang on. I need to have the negative right there. That gives me -31, but it doesn't give me -30, right? So that's why it does not work. What is the solution of the system? We could do substitution or elimination or graph it. If you know me at all, you know I'm going to do elimination. I'm going to multiply the top equation by by 3 and the bottom equation by 2. If you're not sure why, it's kind of like I will get a common denominator out of that because 2 and 3, are the same. So what we're going to get is 15x plus 6y equals 27. On bottom, we get 8x minus 6y equals 88. And then I'm just going to add these two together to get 23x. Those cancel, equals 115. When you divide, you get x equals 5. And you can take that 5 and you can plug it in here, or you can plug it in here. I'm going to choose the bottom one. Why not? So 4 times 5 minus 3y equals 44. 20 minus 3y equals 44. Minus 20 is -3 equals -3y equals 24. And so y equals -8. And if you're not trusting in your work, you could take both of these and plug them in either here or up here and prove yourself right. Find the area of the shape. It's just length times width, so it's 5a minus 2 times 4a plus 3, which is 20a squared, right? Which is 15a, which is minus 8a, and minus 6. We get 20a squared plus 7a minus 6. There's the area. Solve this absolute value equation. I don't know if you remember, but the absolute value of x, if I said it was 3, what number could be inside of here that would make this true? Well, 3 would work because the absolute value of 3 is 3. But also negative 3 works because the absolute value of negative 3 is 3. So how you solve this is you're going to have a positive version and you're going to have a negative version. And then you solve. So subtract 6 to get negative 3 equals negative x. This is x equals 3. And over here, we subtract 6 to get negative 9 equals negative x. And x equals 9. And if you're not sure if both of those work, plug them in. 6 minus 3 is simply 3. The absolute value of 3 is 3. 6 minus 9 is negative 3, and the absolute value of that is 3. So there are your solutions. Well, we've reached the end, and here are all the things that I mentioned. I mean, I probably mentioned a handful of more things that I did not write over here. One that comes to mind is this with the exponential functions, but I definitely talked about it right here, so maybe you could hear me when I talk about that. Let me know if you got any questions, and good luck on the final. See ya.